Hello, dear HVAC professionals. My name is Dr. Ramaswamy. It is my pleasure to welcome you on this HVAC design of healthcare facility, this course. This is a special course designed for practicing HVAC professionals, engineers, to improve their skill in design of HVAC systems of hospitals, healthcare facilities, health centers, polyclinics, etc. This course consists of few modules. Course will cover various topics which were very carefully drawn from the international standards such as ASHRAE, that is American Society of Heating and Refrigeration Air Conditioning Engineers, SIPS, Chartered Institute of Building Service Engineers from UK, and the Health Technical Memorandum. The course curriculum will be sent to you along with the study notes, but generally the course covers many topics such as what is infection control, what are the airborne transmission, isolation rooms, protective environment, and how these factors affect the HVAC design, general ventilation and air change rates, room pressure control, negative pressure, isolation rooms, infection control and ventilation requirements for all the rooms, emergency rooms, and reception areas controls, positive pressure isolation room, infection control and ventilation requirements for operating theaters and operating rooms, anteroom, and its design features. These are some of the topics. Similarly, special design for laboratories and special procedures rooms. Then we also talk about the hospital energy use. And then we also cover zoning of various HVAC system in hospital design. Then we talk about types of chillers and its features in hospital, air handling units and its sizing for hospital, and then recommended elements for air distribution, ductwork installation, noise criteria, HVAC equipment location and installation with a special consideration on air intake and outlet. And we also cover energy conservation on HVAC design in a hospital. And plus, we also talk about HVAC controls in healthcare facilities, BMS, that is Building Management System, and its role in HVAC system and design in the hospital, FCUs like fan coil units and its design features in hospital, then vaccine storages, refrigeration systems, cold rooms, then biosafety cabinet and its design features. And we also cover cryocoolers, particularly using the liquid nitrogen and design and its aspect in hospital. And this is all based on the various international standards, including ASHRAE and SIPS actually in that. This course definitely consists of a lecture to strengthen the skills of the design of HVAC engineers. And then it also consists of some practical case studies with a mock design of operation theaters, ICUs, and its preparation of it, the technical specification. So this course, as I told you, consists of various modules, and this is module number 1 in that. This module briefly covers the basic difference between air conditioning for healthcare facility and that of normal building or other type of industrial building or even the commercial building or residential building. And importance of support system in a hospital and why we need a controlled environment. What is infection control, airborne transmission, what does it mean? Then what is the definition of indoor air quality? Then what are the potential causes for the poor quality in a hospital? Then what are the principal contaminants using poor indoor quality? Because this all you should know when we are designing the hospital, because generally air conditioning engineers normally take the design based on the architectural drawings. So we normally enter into the later stage once the architectural design building floor plans are finalized. Similarly, we also cover in this module HVAC design for the infection control, how we have to have a special type of design based on the international standards, various kinds of filters, ducts, and then relations to the indoor air quality in general. But we will have a detailed study in subsequent modules. Then we also talk about the different kinds of isolation rooms, then various major departments of a typical hospital. This is what we are going to cover in this module in that. So what hospital? Generally, generally when we talk about modern hospital, It is generally hospital main. It is the main purpose is only for the diagnostic and treatment. But the modern hospital is not like that. The modern hospital depends upon various teamwork. Actually, the success of a team of qualified and experienced physician, specialist surgeon, and other specialized personnel who are in the forefront to run the healthcare system heavily depends on an efficient infrastructure support system, including proper HVAC system. The infrastructure support system includes building, specialized diagnostic equipment, and all other services like medical gas, all biomedical life-saving equipments, laboratory equipments, diagnostic equipment, and then including the proper air conditioning, that is heating, ventilation, and air conditioning system. Why controlled environment is required in hospital? Now the so much advances. Now, of course, development is a continuous process. The continual advances in medicine and technology, it necessitates the constant re-evaluation of the air conditioning needs of hospital and its medical facilities. It is not like just promoting a comfort, because we know air conditioning means to control the temperature and humidity. It's a general definition, but it is more than that in a hospital when the definition comes to the hospital air conditioning. And there are various studies and research that told that it is proved that a controlled environment generally have more rapid physical improvement than do those in uncontrolled environment. It's a fact, actually, especially in operation theaters, ICUs, and isolation rooms. And the air conditioning basics and design in while designing healthcare facilities present definitely many problems generally not encountered in the usual comfort air conditioning system design. And nowadays, recently, we talk about everybody knows the indoor air quality. We don't know what type of air we're breathing. We cannot see the air, but air is very dangerous unless otherwise if it is treated properly. So these all requires, especially in the hospital where uh, various sources for the infection. So that's what the air quality is very, very important. And that's what I'm telling that why that indoor air quality is important and how it affects in our hospital air conditioning system design. Generally, I'm talking, this is very general. Maybe this may not be relevant, but I just want emphasis to you why we need to talk about indoor air quality. Because if you see this indoor air quality nowadays, it is emerging as a very, very important topic, not only by practicing engineers, it is even by doctors, pathologists, microbiologists, everybody, even the common man. Everybody wants to know what type of air they are breathing in that, especially in a hospital. So the various researchers have shown that most of the illness is caused by indoor air, basically because of the polluted indoor air. Also shows that majority of the 30 to 70% of the indoor air quality problems involve the HVAC system. So that's what I always used to tell. When we are designing the HVAC system, indoor air quality consideration is very, very important. So that is what this indoor air quality is more important. Again, we know that in air conditioning system, we always take fresh air. And when we are taking the fresh air, from where we are taking, what are the sources, and how it is being treated. And then plus, we also, majority of the people who spends 80 to 90% of their lifetime in their indoors. And we also breathe 15 to 20 kg of air per day. That's whatever the air we are breathing, we should be very careful what type of quality we are doing. And especially in a hospital, in the critical areas, operation theaters, intensive care units, isolation rooms, these all very, very critical areas where the bodies are open, human bodies are opened, and then patients are, their immunity in their body is very, very less. And then visitors will also be there. So these all will definitely prone for the infection to spread easily in that. So that is what we need to have a proper indoor air quality to understand before we start becoming designing in that. Now, generally, what are the defining? How do you know as a HVAC engineer The indoor quality is very, very poor. Many places, many times you go to the hospital, you can find out sometimes throat irritation. You have a dry facial skin, respiratory infection, asthma, fatigue. Sometimes if you stay a long time, it will have a headache. Then you may have some allergic reactions in certain areas. Then we also the sick building syndrome. These are some of the definition for the poor indoor air quality. What are the causes for the poor indoor air quality? They are we are probably the HVAC system. One of the major cause is the HVAC system is not designed properly, and we don't follow the proper ventilation requirement, that is the air changes per hour, not as per the international standards. Because these international standards have been framed after in-depth, very careful, meticulous research and practical considerations by experts. And then there could be a building materials. Many times the owner of the hospital, owner of this thing, they will compromise what type of material they are using in the construction, because that may not be the role of air conditioning engineer, but that may be an architect and the construction team. And plus the poor maintenance of the air conditioning system. Even if you design the best HVAC system with all the facilities, if the AC system is not maintained properly, and that is also one of the causes for the poor indoor air quality in the AC system. Then we also in a hospital, we have a housekeeping, various other agencies, they use different kind of perfumes, different kind of office equipments and all the things. Everything you may create a problem sources for the indoor air quality in that. Now, generally, we call the entire contaminants for the air in, because air conditioning is to treat the air. So outdoor contaminants, because we take the fresh air for ventilation, that is climate, the temperature, because which we have to treat it, and environmental conditions. Noise is also another pollution actually. Indoor contaminants means chemical as well as biological contaminants in that. So when it comes to chemical, from the name itself, you can understand it will be a smoke, VOC, that is called as volatile organic compounds. It comes from furniture, carpets, machinery, then inorganic gases, CO, carbon dioxide, carbon monoxide, dust particles, which is coming from skin faces, which cause allergic reactions and all the things in that. Now, biological contaminants includes mold. Lot of, like for example, in any hospital, if you go, there will be a lot of respiratory care equipment. They produce a lot of mist. So that means it will growth for the mold. And whenever the mold growth is there, even some many times if you don't maintain a proper humidity inside the hospital, in the wall itself, you can see the mold growth will be there, funky. And 90%, it is reported that 9% of the reported hospital infections between some 1986 to 92 were caused by the funky. This is in one of the developed countries. These are research purpose in that. Then bacterial infection by coughing, sneezing, and then all this type. Then water through water also. Then come to the viruses. And this we know that even latest COVID-19 also it's another important thing. We all have just come out from that issue of COVID-19. Just still we are not many countries still they are struggling in that. So these all basically biological contaminants when we are designing air conditioning system. As I told you, we need fresh air for ventilation purpose, because you all are air conditioning engineers. We know generally we have certain standards for the air changes, that is air change per hour. We also normally take a lot of fresh air depending upon to maintain the level of ventilation requirement based on the international standards. And that is basically to maintain the proper quality. And then we also recently, some new technologies have come like variable air volume, variable frequency drives. Because whenever we take more fresh air, more energy, because outside air when we are taking, definitely to treat it again, it needs more energy in that. So we are also very conscious about the energy conservation. We have to be very, very careful about the fresh air what we are taking. We have to have, generally everybody recommends as much as possible, we will have to have a high recirculation and filtration, but there is a limitation. And if filtration also, if we have a bad filtration control, it may not filter the proper the contaminants. And so then recycled air also keeps the ducts, the particles to accumulate in the ducts. So these are some of the potential problems with the ventilation system. In fact, there is a National Association of Duct Cleaning, and they have come out with very good standards about 10, 15 years ago. They strongly recommend every 3 to 4 years, the entire ducting system should be cleaned by sending robotic cameras and see the condition of the ducts. Probably I'm going to show some of the diagram figures. What we have seen now, duct cleaning is another important business activity in majority of the hospital areas. And some countries, it has become a statutory requirement that the duct has to be cleaned every once in 3 to 4 years in that. And as I told you, majority of the time we spend in the indoor, and if we have a poor quality, definitely it affects the productivity. So these are some of the graphs which I have shown taken from the Chartered Institute of Building Service research paper in that. So generally, airborne infection risk, is there a risk? Yes, definitely. If you see chickenpox, tuberculosis, these all highly contagious disease, even including now the COVID. So these airborne diseases will definitely create the infection in that, and that spreads so much fast. And that will, once it is in the it mixed in the air and it is get recirculated, then it goes everywhere in that. So that is very important. That is how we have to have a design of our air conditioning system very carefully based on the standards. So now, having said all the things, now let us see what are the basic difference between air conditioning for the hospital and that for the other buildings. Because in a hospital, we have a different departments, starting from OPD, that is outpatient department. Then we have a special department called as indoor patient department, ward area, different ward areas got the different requirement. Then operation critical departments like accident emergency, operation theater, intensive care unit, then burn unit, SCABU, many things actually. Then we have also X-ray departments. Then we have a cyclotron facility, medical research, oncology department, where we prepare so much medicines and all the things. So every department in a typical hospital has different conditions of air, different conditions of quality of air we maintain. So we have everything is as per the ASHRAE standard. In fact, ASHRAE has a special requirement for the design of hospital in that. So that we will see in the subsequent modules also. And the system design need to permit accurate and specific control of the environmental condition. That is also the thing. Like if it is in a comfort condition, okay, we always tell 22 plus or minus 2 degree, or 23 to 5, even if it goes 26, or even if it goes 21, normal places, it is not going to affect. When I'm designing a air conditioning system for comfort of office area, comfort zone, and it is not going to much in that. But when you are giving hospital, because people who are in the hospital, they are already sick, and then they are also very potential source for spreading the infection. There are visitors, doctors, the healthcare workers, all these things and that. So there is a separate department called as infection control department. If you go to any hospital, there is a infection control department. In that, we have a pathologist, microbiologist. Time to time, they also take a swab test from various areas and they test it. They test the quality, and in order to ensure that the infection is within the controlled rate as per the standards in that. Generally, these are some of the general technique. As you all are HVAC engineers, so you know that various methodology we use for the HVAC design. As I told you, design is an art. It comes by experience. Then we have to also have a proper space planning, especially the space allocated by the architects. They have their own way of allocating the space. And because they don't consider as air conditioning as a very critical. For them, aesthetic and the process requirement is very important. They focus on that. So it is our duty there as air conditioning professionals to make them to understand a proper space for plant room, for spacious plant room, so that it needs proper maintenance. I have seen many times the architects, they don't give a lot the proper space, and then the equipments are designed and they installed later. It's very difficult to even to go and maintain the equipment. These all. So we need to understand when we are designing air conditioning system in that. And then we also very specifically to understand about the very clear various areas we have to have a segregated various areas, sterile areas, dirty materials movement, how, like, for example, operation theaters and all the things, how these uh, tools which is used for the operation theaters, surgical tools, how we have to move it. There should be a separate corridor because, and that corridor has to come. Then we have also a kitchen, restrooms, toilet. So these all various places in an hospital, and so this all we have to have a proper standard we have to use for the space design. So this all Australia has very meticulously formed various standards for these things in that. As much as possible, some of the features for the infection control, we have to very careful about the individual zoning to reduce the cross infection, particularly as I told you, isolation rooms. And then because what do you mean by isolation room? We always isolate a patient, people who are infected with COVID or even tuberculosis, chickenpox, like that, which is highly contagious in that. And then we have to also design our air movement depending upon what type of flow, how much air we have to discharge, and what type of velocity, what type of flow it should be, so that even not, anything should not settle on the floor and all the things. We have also positive and negative pressure design, pressure of the room side also. Humidity is also another important things. And this all based on the general parameters as a HVAC design engineer, you should always keep in your mind. And then I'm just talking about, some of these viruses, bacteria you cannot see. So you can, when you take the swab and you send this to the laboratory in the microscope, this shows actually how this problem. And then we also, as I told you, we are going to study very detailed about the filtration. We have different kinds of filters, free filters, fine filters. Some places we use, mostly in OT, we use HIFA filters. And then we also, based on that, we also define as a clean room actually in that. And then when it comes to isolation rooms, we have two types generally when we talk about isolation room, because as I told you, any patients who are infected, they should be kept in isolation rooms. One is airborne infection isolation room, that is AIA room. It refers to the isolation of patients infected with the organism spread via airborne droplet, which is airborne droplet, which it is less than 5 micrometer in diameter. These include patients suffering from measles, chickenpox, and tuberculosis, like that. Just an this one in that. Then we have also a PE room, that is a protective environment room. And it is basically a specialized area for the patient who have undergone hematopoietic stem cell transplant, and then HIV. Then we have diabetes, cancer, radiation therapy, and all these types. This is called as a PE rooms in that. These are the two type of isolation rooms we are going to talk. Now, how this classification affect as a air conditioning design engineer, how it is going to affect? The differentiating factor between that these two rooms is the pressure relationship. The protective environment, the PE rooms are set positive air pressure related to the adjoining space. You have to have the relation actually. These areas require frequent air changes, which is approximately greater than 12 per hour, and requires all supply air passing through the high efficiency particulate filters. That means all outdoor air and very energy expensive, no recirculation. The isolation rooms housing the infectious patients must be maintained at a negative pressure. That's what normally, if you see most of the time, the negative pressure. What does it mean? These areas require frequent air changes and require all supply to be exhausted without recirculation. That is also another important fact. So both these areas require inline monitoring to ensure that they remain under a certain amount of pressure. The room should be self-closing, and the walls, windows, ceiling, floor, and penetrations all well sealed. But this may not be your HVAC engineer's work. It's an architect, but it is our duty to inform to the architect when they are doing all the things. Let us see now different kinds of department, like for example, surgery and critical area. In that, where what are the surgery? There only the body is open. So the relative humidity, set point temperature, these all various standards as I have specifically given actually. And then inside also, inside the theater, there should be a controllers to control the temperature and humidity, because every patient has got a different kind of inside temperature requirement like that. Similarly, OB and gynecology area, delivery rooms, recovery rooms, there are various standards. This should be also, it is maintained at positive pressure. Then we have also various kinds of nursery suites. Then patient rooms, I told you, the individual temperature control in the ward area. And then we have laboratories. We have regulated temperatures. And in the lab, we have different kind of biological lab, actually, the fume hood. And then we have also safety cabinets. And these all safety cabinets also been categorized various classes, class 1, class 2, class 3, like that, as per the ASHRAE applications. This all probably we will see in the when we do design a particular area, that will be put in that. Then we also design the newborn anti rooms, and before we enter into the critical areas, this is also what is important and for this purpose. Now, generally, we talk about possible airflow control design, which differ in pressure relationship of anteroom to the isolation room and the corridor, because we have a corridor, then after that we have anteroom, then we have isolation. Generally, what are the relations? This is a general. Anteroom negative to both isolation room and corridor. So this design has two advantages. There is no need to supply air and to delicately balance the anteroom. And if the anteroom becomes contaminated, there's still a pressure buffer between the anteroom and the corridor. The disadvantage is, since the anteroom is negative with respect to the corridor, the chance of contaminating the anteroom is higher because it's negative in that. Now, when the anteroom is positive to both isolation room and corridor, it has got some advantages, it has got some disadvantages. What are the advantages? We need not to exhaust air from and delicately balance the anteroom. And since the anteroom is positive with respect to the corridor, the change of contaminating the anteroom is lower, the chance actually. The disadvantage is, if the anteroom does become contaminated, it is likely that isolation room will become contaminated as well as. So this design is not recommended. So anteroom is neutral, net neutral, or negative to isolation room, and positive. Various options. And just you can check out. This all we see when we really do the case studies, when we design actually in that. But in general, the general design considerations are general design. This is just for general purpose, because the first module I just briefly explained what we are going to talk. So the general design considerations, the plant should be, any air conditioning plant should be located so that it is remote from possible sources of contaminations and heat gains. Most of the air handling units should be located in an accessible area, secured from unauthorized entry. Then all ventilation systems should be clearly identified with a permanent label. Organic material or substances that can support the growth of microorganisms cannot be used in the construction of the plant and its equipment. Then access to the elements that require routine services such as filters, fans, and all type of heat transfer devices should be via hinged doors. That is also very, very important from the operating point of view. And then we should also have each filter's pressure drop is to be monitored by a sensor, and it should be linked to the BMS system. So these are some of the general AC consideration in that. So generally, with this, probably I'm going to complete my presentation. But what I mean to say, in general, this module 1, it's a general introduction about this course. And in subsequent modules, we will talk in more detail, and we will also design, because the time limit for each module is about 20 minutes only. And then later, probably interactive session, there'll be a question answers, and there'll be a demo classes also in that. So thank you very much. And God bless you all. Thanks.